verify the following. This set of points are vertices of a parallelogram. For such question, you have to know the property of the following structure. If you're not thorough with that, don't attempt that question. Okay, actually you can to an extent of writing the formula. So you'll get half a mark also. If not, the fundamental aspect of the structure, if you don't know, then you can't prove it. Okay, coming to this question. So we have point A, which is minus 1, 2, 1. Point B, which is 1, minus 2, 5. So you have to take in the same order. Point C is this and point D is this. Let's name them A, B, C, D. You can't change the order. Either you go it in clockwise direction or anti-clockwise direction from any point, not an issue, but you can't change the order. You can't go zigzag. That's what I mean. A, B, C, D is not possible. It should not be taken in that order is my point. Okay. Now, so how do you prove it? How do you prove something is a parallelogram? Simple. A quadrilateral be a parallelogram in many ways. So starting off with the diagonals bisect each other. They might not be equal in length, but they bisect each other. Opposite sides are equal, so on and so forth. Okay, there are many ways of proving it, and opposite sides are parallel and all of that. Okay, so what to use over here? It's left to you guys. You want to prove that this point is the midpoint of both the lines. That's good enough. Okay, or you want to prove that opposite sides are equal. That's also good enough. Right? So here I feel that, since we don't know for the midpoint and section formula and all of that for this particular setup, we have to go with proving that opposite sides are equal. Again, we can use many concepts actually. We can show that slope of AB is same as DC, right? There are many ways of solving this. Let me write all of them. Not all, of course, some of them. So one is slope, that is prove opposite sides are parallel. Next is length. Okay, that is opposite sides are equal. Then the midpoint formula. That is the diagonals. Okay, I'm not writing all of it. You guys write it. That is the diagonals bisect each other at this point. So this is the midpoint for both the diagonals. So if you prove any one of this, you are done basically. Okay, since we are dealing with distance formula, I'll just go with that. Since we don't have any other variation in this topic, I'm just going with this. Of course, in your final exam, whatever you guys want to do, you can use that. If you learned a particular concept in any other chapter, you can use it over here. Okay, so distance formula talks about the difference between the coordinate, the square of that. To the power of half. And now we have to figure out AB, DC, and so on and so forth. So AB square is equal to, so whatever is convenient guys, just do that. So we'll directly go with writing 2 square. Then this is plus 4 square. And this is 4 square. So this would be 4 plus 16 plus 16, 32, 32, 36. Oh, yeah, 32, 36. So what am I thinking of? 6. So AB is equal to 6 units. Then we have DC. I'm just doing the opposite side. So we have 2 square again. Then this would be minus 7 plus 3 or 7, or I can go with minus 3 plus 7, that is 4 square again. And this 2 is again 4 square. So this 2 will result in 6 units. Then we have BC square, which is equal to 3 square plus 5 square plus 3 square. So that would be 9 plus 25 plus 9. So this would be 47, I guess. 18. No, wait. 25 and how much is this, guys? 20. If I take 45, 43. So BC is square root of 43. And finally, even AD has to be the same. AD square would be 3 square plus this would be 5 square plus 3 square. Same thing, right? Yeah. So AD2 is root of, did I do the math right? 43, yeah, 43. Then we'll write a general statement that as opposite sides, or we can conclude this is equal to BC, this is equal to AB. So that, we are not missing anything. As opposite sides of the quad are equal, from this we can infer that ABCD is a parallelogram. Is it show that question? Verify that.